Okay, we're going to continue on with our derivatives videos. So we've covered power rule, product rule, quotient rule, and chain rule. Our last type of derivative that is quite common is when we deal with a product rule, but we have a chain rule combined with it. So I like to call them chain rule combos because it's the chain rule part that sort of makes things a little bit more confusing. A lot of students struggle with this one the most, and it's not so much that the derivatives cause the problems, it's the factoring, common factoring, and the simplifying at the end. So we'll do some examples of that today just so you can kind of get the hang of it, and once you do, the rest is pretty straightforward. So sometimes these typically, I would say, are one of the hardest topics of the course. And it's just because we no longer have a single chain rule, and we no longer have a product rule, we kind of have both together in one. So if this was just 3x squared times 2 minus x squared without the cubed, we could just FOIL that out and do power rule, or we could leave it the way it is and do product rule. Those would both be pretty easy. If this question had just the 3 in front without the x squared, and we had a cube still, now that would be just the chain rule, right? We could bring the 3 down, make it a 9, drop our power to 2, and so on. So without the x in front, it works good as a chain rule. Without the cubed, it works good as a product rule. It's when they're mixed together that we run into a problem. So how you want to approach these questions is you want to treat it as a product rule. And this is probably the only kind of question I would typically use a product rule for, because it's usually easier just to FOIL it out anyway. So, but let's follow the product rule formula. So remember, when we do the product rule, our derivative is, we do the derivative of f times g, and then the other way around, f times the derivative of g. So you can see what we're going to have to do is we're just going to have to figure out each of those separately. So for our f term, that's the easy one. Our derivative is 3x squared. Our question is 3x squared, so our derivative would be 6x. For g, you can see the issue becomes g by itself is a chain rule. So we just have to follow the chain rule steps. So bring the 3 down, drop it to a 2, and then times it by the derivative of the inside, which is negative 2x. So let's simplify that to be negative 6x out front, and the rest of the bracket stays the same. So separating them into a product rule, it actually isn't too bad, where one half is just a regular power rule, the other half was a chain rule. So now when we follow the rest of the product rule steps, this is where it gets to be a little bit tricky. So we do our regular product rule, so let's multiply those two first. So we'd have 6x times our top value of g, and then we would do plus the other two. So we have 3x squared times negative 6x, that gives us negative 18x cubed, times our bottom bracket, so 2 minus x squared squared. Okay, so that's not so bad. Let's just get rid of that plus, because the plus and minus together, we can just treat it as a subtraction. So if we stop there, we've got the right product rule, but we haven't simplified it far enough. So this is where the rest of these questions get a little bit trickier. It's not so much the product rule or the chain rule, it's how do we simplify. So we have to treat this just like regular common factoring that we've done before. So let's just look at a basic couple examples before we finish off this question. So if I gave you something like 4x squared minus 8x cubed, and let's put on a 2x or something like that. Actually, let's just do two terms. We're never going to get more than two terms with these questions. Let me get rid of this first one maybe. Let's just leave it as 8x cubed minus 2x to the fourth. So if that was our question, our common factor would be, we'd take out a 2. I'll write it over on this side. Take out a 2. We could take out an x cubed. And then our leftovers would be 4 plus x. Right, so with common factoring, we take out our smallest common coefficient, take out our smallest exponent, and then just divide each of those terms by that common factor. So that works pretty easy. The ones where people start to struggle a little bit is what happens if I gave you a question that looked, let's change it up a little bit harder. So let's suppose we had something like x cubed minus 1 squared, and then we had another one that was x cubed minus 1 to the 3. And let's put some x's in front. Let's call this one x cubed, and let's call this one x. Okay, so this is kind of getting closer to what our question is above. So with these kind of questions, we still have the common factor, but you pull out your smallest coefficient, which in this case is x, take out your smallest bracket, which would be x cubed minus 1 squared, and now the rest of the common factoring gets a little bit weird. So remember, we're dividing all of these things by our common factor. So x cubed divided by x would give us x squared. This one divided by that one would cancel because they're both exactly the same. Then we do the same thing for the second term. X divided by x would cancel, and then that bracket divided by bracket is the same thing, except one's cubed, one's squared. So when we subtract those, you'd have to the power of 1. And that's as far as we'd go. So in this case, we can't really do any combining with the rest of the brackets. With the questions that we're doing here with the chain rule and product rule, we will be able to combine these because they're always going to be one apart. So let's finish this one off and you'll see what I mean by that. So you want to still pull out your common factors. That doesn't change your steps. Pull out your common factors for the questions. Figure out what's left over. It's that leftover part that we're going to have to do a little bit more work with most of these questions. So let's finish this one. So looking at the 6x and the 18x cubed, our common factor for those would be 6x. Then if we look at the brackets, take out the smallest power, which would be 2 minus x squared squared. Okay. Now we got to figure out what's left over. So divide these out. 6x divided by 6x is 1. The brackets cubed divided by brackets squared would be just the brackets to the power of 1. So we'll just keep it in brackets so we kind of remember what that is. Then do the same thing for the second one. 18x cubed divided by 6x would give you 3x squared. And the brackets squared divided by brackets squared would cancel. And we're almost done. So the only thing we want to do is simplify this bracket out. So we have 2 minus x squared minus 3x squared. So let's put those together to be minus 4x squared plus 2. And we can even take out a 2 if we want. That might make it a little bit easier. So let's make it 2 times negative 2x squared plus 1. And that's it. So now all we're going to do is put that with our other common factors that we had. So our final answer, let's bring that 2 to the front. So that'd be 12x. And we can do our factor that we just had, minus 2x plus 1. And our other common factor we had at the very beginning was 2 minus x squared squared. And that's how we'd write our final answer. The order of them doesn't matter. You could put the brackets in whatever order you want. These are all just being multiplied, so it really doesn't matter too much what order you write them in. So let's try another one. It's almost the same sort of scenario, just bigger brackets, but it doesn't make too much of a difference. So again, let's call this one the f term. Let's call that one the g term. So when we do our product rule, f will be our x squared minus 1 term, so that derivative is a chain rule. So you can see we just get the same product rule setup, except both of them this time have a chain rule. So this one would be 8x times our brackets cubed, and we do the same thing for the g set of brackets. So that one will be 2 minus 3x cubed. So that derivative would be, bring the 3 down, drop it to a squared, and times by the derivative, which is negative 3. So simplifying that, we would get negative 9 times 2 minus 3x squared. So that's it. So we want to again do our product rule. So it'll be those two multiplied together. So let's write that step out first. So we'll do our overall derivative would be, let's do the 8x and the cubed. Let's do the bottom one first, times the top one. Okay, so those are both cubed. And then we're going to do the same thing, but we're going to do the other two diagonals. So that one times that one. So let's keep that separate colors. So we're going to add them, but you can see there's a negative 9 on there. So we'll just change it to subtraction. So it'll be this bottom one times the top one. And again, the order of these don't matter. You can put them in whatever order you want when you're multiplying them. Just the adding and subtracting part matters, that's it. And that's pretty good. So we've got our product rule figured out. So now the rest of it now is just common factoring and simplifying. So if we compare our 8x and the -9, there are no common factors for that. So we don't need to worry about that one. If we compare our x squared minus 1, the smaller one is the cubed in the first product rule. The second one was the 4. And then when we compare the other bracket, the smaller one was the squared. So now we got to figure out what's left over. So when we divide each of these out, we have an 8x left over in the first set, in the red set. The x squared minus 1's cancel, but we have an extra 2 minus 3x to the power of 1. These will always be to the power of 1, because when we're doing the derivatives, we're always dropping our power by 1. So our common factors should also be different by 1. So for the second set, the 9 stays the same. The 2 minus 3x cancels, but now in this time we have an extra x squared minus 1 left over. And that's it. So you can see these square brackets that I write. I like to put square brackets because it keeps you simplifying to remember what you need to do next. So now if we FOIL all these out, we would have 16x minus 24x squared. And for the other one, we got minus 9x squared plus 9. So let's put those together. So we'd have negative 33x squared plus 16x plus 9. And I don't think there's a common factor in there anywhere. Doesn't look like it. I don't think we could factor those. 33 would be like 11 and 3. I can't see it. 11 plus 9. Nope, we'll just leave it like that. Even if it does factor, I don't think we need to. And then let's just leave the rest of our question the same. So that would be our final answer for this question. So pull out your common factor, figure out what's left over, and then simplify that leftover part. And that's all there is to these questions. So once you do a few of them and you kind of get the hang of it, most people get quite good at doing this. Okay, if you get a question that looks like a product or a quotient rule instead of a product rule, we don't want to mix chain rule with quotient rule. It works, but it tends to be a little messy, tends to be quite a bit tougher to simplify. So my advice for these is to change them first to a product rule. So for this first question, let's rewrite it as x to the 4th times 2x minus 3 to the negative a half. Right? Just like we did with chain rules before, we can still do the same thing here. Now, once we do that, the rest of the question is basically the same as what we just did. So let's call f our x to the 4th. So our derivative of that is 4x cubed. For the second one, 2x minus 3 to the negative half. The derivative of that would be negative 1/2. 2x minus 3 to the negative 3/2 when we take away 1, and derivative of the inside is 2. So you can see that half out front and the 2 would cancel. So we should just have negative 2x minus 3 to the negative 3/2. And that's it. So follow our product rule steps again. So our overall derivative would be the two diagonals multiplied. So let's go 4x cubed times 2x minus 3 to the negative 1/2. And the other one has a negative in there, so when we multiply those and add, it'd be negative x to the 4th times 2x minus 3 to the negative 3/2. Okay, so you can see this one simplifies actually quite nice once you do your product rule. Now our last step is to pull out our common factors. So we have a 4, which isn't common, but we got x cubed out of the front terms. And our smaller power of the brackets will be 2x minus 3 to the negative 3/2. So now our leftover part is ready to go. Divide it out, we get a 4, and we have one set of brackets left over, the 2x minus 3. Right? The negative 1/2 take away negative 3/2 would give us plus plus, which would give us 2/2, which is equal to 1. So again, all of our when you do these common factorings, you should always get an exponent of 1 on the brackets. If you don't, you did something wrong. Okay, so once we pull out our common factor to the first, we're ready for our common factor in the second one. So the second one we have x to the fourth divided by x cubed, which would be x, and the brackets cancel. So let's just simplify the brackets. We have 8x minus 12 minus x. Put that together to be 7x minus 12, and we're done. Our common factors that we had at the beginning stay the same. And that should be our final solution for that one. Okay, so if you ever get a division, change it to a product. It'll save you quite a bit of headache in terms of the simplifying. Okay, let's try another one. So this one we have another division question. So let's rewrite it as x times our bottom to the -3. And again, from here on we're doing a product. So let's call f our x term. The derivative of that is just 1, which is nice. Our g is our brackets. And the derivative of that is just a regular chain rule, so that's not so bad. But we brought it to the top, so that makes it negative. So bring the negative down, drop it to a -4, and times by the derivative of the inside, which is 2. So let's simplify that to -6. And we're ready to go. So let's do our product rule. So let's multiply those two first. So the 1 doesn't do anything. So 2x minus 3 to the -3 is our first product. And then we're going to add the other 2. So we have -6 times x and our bottom bracket. And again, that's basically it. So pull out our common factor. There's no common factors in the front this time. It'll just be our brackets. And we always take out our smallest power. So now our leftover when we divide these out would be 2x minus 3 for the first part to the power of 1. And for the second part, we'd have just the -6x left over. So just like we did with the last one, let's put those together. So 2x minus 6x would be -4x minus 3. And that's it. So I'd write our final answer as -4x minus 3 times our original common factor, 2x minus 3 to the -4. Okay, so with these, do the product chain combo. You don't want to try to do quotient. You can try quotient if you want. It'll end up being the same thing, but it does take a few more steps to simplify. Our last thing we're going to look at today is what happens when we have chain rules inside of chain rules. We looked at these in the last lesson where it was just a chain inside a chain, but we didn't have to worry about it too much because the chains were pretty simple by themselves. So for this one, the issue is we have a chain inside of a chain, inside of a chain. But again, they're fairly straightforward, so you just got to be careful of the steps. So with these kind of questions, I often like to think of them as being kind of like those Russian dolls. Take the outside layer off, work on the inside, then take that layer off, work on the one on the inside of that, and just keep going inwards all the way along. So the only thing I would do with this one to start with is let's change these two brackets, and let's make them to the power of a half. So our outside square root would be a half. Then we have another inside one, so we'd have another x plus x to the half to the half. Okay, so I think we got it right. So our x to the half on the inside plus x square rooted, which would be another half, and then x plus that answer to the half again. And we're good. So with this one, we would deal with outside in. We don't need to do product rule or anything like that. We just got to be really careful with our chain rule steps. So let's bring the half on the outside down first. So it would be half to the -1/2. Everything inside of that original bracket stays the same. Don't start doing any derivatives yet. Okay, so that takes care of our outside square root. Now we got to do the derivative of the inside. Well, the derivative of the inside is derivative of x would just be 1, and now we got to do the derivative of, so we do the derivative of the x, which is 1. Now we got to do the derivative of that nether bracket. And you can see that bracket turns into another chain rule. So bring the half down, drop it to -1/2 again, which would be x plus x to the half. Again, that doesn't change. So that's our inside bracket. Now, the derivative of that we still have to do, right? Because our product rule was derivative of the x was 1, derivative of the first bracket gave us what I wrote in black, but not because that was another chain rule, we got to do derivative of the inside of that as well. So just dealing with the inside part, the derivative of the, here I'll write it in a different color. So the derivative of what I wrote in black, we only need to worry about the inside. So the derivative of that inside part would be 1 plus 1/2 x to the negative 1/2. And we're done. So you can see I sort of did the red outside bracket first, then I did the derivative of the inside, which was the black part. So the x gave me the 1, and then the derivative of the second brackets was another chain rule. And then because it was brackets, we had to do the derivative of the inside of that one, which was the blue chain rule part. And with these questions, you can't really simplify them. Just leave it exactly like that is totally fine. If you wanted to switch them back to roots, you could, but it gets quite complicated. So we'll just leave it there. We don't need to. And I have one more example. So this one looks similar to the one we just did, but it's a little bit more complicated because it's not just x plus a root inside the big root, it's times. So for this one, we're going to get a product rule. So I would again change these two brackets. So this would be x times x plus 1 to the half. So we can still do the outside derivative, that doesn't change. So let's bring the half down, drop it to negative half. So there's our outside derivative. The rest stays the same. But now the derivative of the inside is a little bit more complicated because that inside is being multiplied together. So we have to do the f times g thing. So let's write it over here on the side. If f is x, f prime is 1, g is x plus 1 to the half. Derivative of that would be 1/2 x plus 1 to the negative half. And times the derivative of the inside, which is just 1, so it doesn't do anything. Now let's simplify this before we go back to our original question. So we would get 1 times x plus 1 to the half, plus the other two would be 1/2 x times x plus 1 to the negative half. And just like we did with our other product rules, we can simplify those. So let's take out our x plus 1 to the negative half as our common factor, and we'd have an extra x plus 1 left over, and that extra 1/2 x. So we can put those together to be x plus 1 to the negative 1/2, and that would be 3/2 x plus 1. That's an x. It looks kind of messy. Let's fix that a little bit. And that's it. So that's our derivative of just the inside part. So we need to basically just combine that over with our outside derivative. So our final answer for this one should be 1/2 with our outside brackets like we had originally written in black. And then the derivative of the inside turned into this product rule. And let's just put our final simplified answer for that one. So x plus 1 to the negative 1/2 times 3/2 x plus 1. And again, the order of these don't matter because they're all being multiplied. If we really wanted to be fancy, some people would combine that with the 1/2. So if you wanted to bring that 3/2 up front, you could FOIL that out if you want and rate it as like 3/4 x plus 1/2. And then the rest of the brackets would stay the same. I won't bother filling in the brackets. Or we could even have factored out another 1/2 if we wanted to. So you could have wrote it as 1/4 and then 3x plus 2. And then the other brackets stay the same again. It's totally up to you on how much you want to simplify those. So you could have left it just the way we had the original one. That's totally fine. The other two is just simplifying those front factors. It's up to you how far you want to go with those. And that's it. So hopefully this gives you a good idea how to do the combo questions. Our next topic is implicit, which is a little bit of a different way of doing it, but this stuff today is probably the hardest that we're going to see for this unit and even for the whole course. So hopefully you understand it and keep practicing, and we'll move on to new stuff in the next lesson.